drilling. Can everybody hear me all right? All right, perfect. So today's EnRoute webinar will be on drilling. First of all, we'll be covering the drilling strategies, and afterwards we'll dive into some of the more advanced parameters that you can choose for drilling. So we'll start out with the drill circle. It's a fairly simple strategy. What you do is you can select your drill here, you set your depth, you can define a diameter for the circle you want to put your drills along. Here you can choose your angle, which will define how the drills will be positioned on the circle. Just leave it at 0 for now. We'll choose 8. You can choose the coordinate of the center of the circle, or you can just define it by graphic. And then you can click on your plate, and as you can see, it will now have put the drill points that I've defined in the strategy. If we go ahead and change this angle to, for example, 15, you'll notice that the drills are now placed in a different position along that circle's edge. The next strategy would be the drill array. Let's again select our 5mm drill, and we'll go to a depth of 5. So for this array drilling strategy, you can choose the columns and rows, so the amount of drills you want across the X and the Y. And for the spacing here, you can define them by an overall width. So for example, we could say we want this along a width of 400 millimeters. And for the spacing, let's say we want, let's say 50 in between of the rows. Then you can define this by XY coordinates or by graphic as well. And as you can see, if we click the left bottom drill of the array will be used to as the main coordinate to position this. You also, for spacing wise, or you can define it by horizontal spacing. So let's say if you want to put in variable shelving holes, then you can set that up like this. For the height, we'll just leave it at 250. So that would be for the depth of the cabinet. Let me just check. Seem to be having a minor issue with this. We'll just leave that for now. Let me just hit OK here and then apply it. And as you can see now, it will have made a spacing of 32 mils in between each center of the drills, which would be ideal for drill banks that you can run on machines. And then for this designing the cabinet, you could, or the side of the cabinets, you could actually just draw a rectangle around it and then center both of these, and then run this twice to create a side for a cabinet with adjustable shelf. The next strategy is, of course, the drill centers. For that, I will draw a few circles on the plate. Let me just quickly create 2 of them. And for these, we'll also define the diameter. 8, for example, reflecting the sizes of the drills that we would like to have. Okay, here as well. Of course, you can also define any shape on your plate and then go to the drill centers strategy. Some of you will also recognize this strategy for the that is used in the ATP. So to apply this to the DXF files that will be automatically processed. So for this one, of course, we also choose the drill, and then we have the possibility to apply this to all contours or to circles only. So as you can see, it will now also put a drill in the center of the squares here. Let me just go one step back. Alternatively, you can also define this for circles only, and you could also choose to do this by diameter. So let's say if you get a DXF file with a bunch of drill holes, let me just create a multi-copy of this, make multiple rows of these, so they're all mixed up. Then we would have the possibility to simply select all of them, go to our drill center strategy, define our 5 mil drill, and then say here that we would like to apply this to the circles that have a diameter of 5 millimeters. And we could, for example, put a 0.1 millimeter tolerance to this. And then when we hit apply, as you can see, it will only have applied them to these 5 millimeter holes. And of course, we can then also do the same. I'll just go to 8 and then set this to 8. And that way, when you receive a DXF that has no layers, you can quite quickly process those drill holes of those as well. Then our last one that we'll be discussing, so the drill corner strategy will simply allow you to put drill holes along the corners of your plate. Of course, you'll need to have a plate defined for to use this strategy. To drill along a contour, let me just draw a few contours. Let me get a square on here as well, or rectangle rather. So we select the rectangle and then we choose our drill contours strategy. Here we again choose one of the drills. We set our depth, and then we have several parameters here that we can choose. So we can define a number of holes. Let's say we'll just pick 10 of them, and we can define a spacing here as well. So we'll set them every, let's say 70 millimeters. And then the spacing type, you can actually choose to prioritize several things. You can choose to hold number, hold the spacing, hold numbers at a certain spacing, put it at all corners, just the inside corners or the outside corners. So as you can see, if we just choose hold numbers, it's going to disregard the spacing and simply put the amount of drill holes that we defined in there on this contour. Let me just choose a bigger drill so it's easier to see. If we hold spacing, then it's going to put more drill holes as we've defined as a number, of course, because it's prioritizing spacing. And if it won't have enough space to fit a drill hole in there anymore according to the spacing that we've defined, but we want one in there anyway, we can also set it to force the last drill. So it will put one more drill in there even though the spacing does not match. So here, as you can see, it has not respected the spacing that we've chosen, but it's added an extra drill in here anywhere to match the spacing between these two. For drilling the corners, obviously it will just put a drill point on each of these corners. And you can also choose inside or outside corners. It'll make more sense if I show you that on this contour. As you can see, the contour is going from left to right. And then if we choose, for example, the inside corners, you'll notice that it'll only put the drill holes when it's making a corner to the right. And alternatively, the outside corners will be when it's making a corner to the left. As for the advanced parameters, let's just step into a standard drill point. We'll maybe pick a 10 millimeter drill here as well. We'll define our depth to 10. Let's make it 50. And then we here, by clicking the 3 dots here, we step into the advanced parameters. As you can see here, you can define the size of the hole by the diameter of the tool or by an exact diameter. Diameter of the tool will, of course, work for all drills. So you'll use a 5 millimeter drill to drill 5 millimeter holes. If I try to select this, as you can see, a drill can only drill by the diameter of the tool. If you wish to set an exact diameter, you'll need to select a drill bit that is able to route over the X and Y axis as well. So for this one, we would have to choose an end mill. Let's get rid of this drill. As you can see here, this is a 6 millimeter end mill. And if we choose the exact diameter, we can set that up here. So let's say we only have a 6 millimeter bit, but we want to drill a hole of a diameter of 10. What that will do is it will actually create a circle with, let's go here. So what that will do is it'll actually create a female offset, basically. But the thing with this is that it will still be defined as a drill, which would make it more easily handled when you're outputting for the strategy order. So in most cases, you'll first want to do all of your drills and then continue with your other strategies. And this would let you keep these holes as drills instead of having to deal with them as routing offsets. So for ordering, that will make it more easy. And let's remove this one and go further. Let me just delete this one again and move back to the standard drills. For the countersink, what that will actually allow you to do is select a taper tool or a conic or engraving tool. And then if you go back in here and say that that's the great countersink, here you'll be able to choose your diameter. And as you can see, then the depth will automatically be calculated. Perhaps for this one, we'll have to do that for a more appropriate size tool. So we'll go for a 3 millimeter drill. We'll drill to a depth of, let's say, 12. And we'll add our conic tool. We'll go in here and choose a countersink of a 5mm diameter. And as you can see here, now it will go to a depth of 2.5. And then if we look at it in the perspective view, you'll notice that it will drill down and then use the conic bit to drill down to 2.5. This is to make it possible. So for example, if you're pre-drilling a hole for a screw, that the head of the screw will be able to go into this hole so that it will be flush with the surface of the material. Let's step back into the parameters. So we'll select again our 10mm drill. Here we have the possibility to check or uncheck depth to shoulder. What this means actually, maybe we'll have to go look at the shape of a drill. So we'll go into our tool library. We'll just go by type, and then we'll go into the 10mm drill. So as you can see, the way a drill bit is shaped, you'll have your H1 value. Here is your shoulder, and then you'll have your H2 value. If you choose to drill to depth to shoulder, it will, in the output file, show you the depth that you've chosen. So for example, 5mm, and then it will add the H2 value. So it will go a little bit deeper than you've defined. If you uncheck it, of course, it will use the tip of the drill to go to the depth that you've defined. Of course, for an end mill, you will not be able to uncheck this because an end mill has just a flat tip. Of course, here you simply can set your depths. In the passes tab here, of course, you'll have your maximum per pass defined by your tool, an actual per pass that you can see. If we change this value here, it will modify the depth of material that's routed away per pass. And the last value here is your pec lift. So if you set up multiple passes, it will, between passes, always lift the drill up to the material surface. The pec lift will allow you to define how much you want to lift it. So let's say here we'll go per pass to a depth of 3.3. If we set this to 1, it will, for each pass, go 3.3 into the material and then lift up 1mm. Or, I mean, of course, you can, if you have less passes, for example, you can set this to 3. And you can use this one to clear out material without having to lift the tool, or clear out chips of the material without having to lift the tool completely out of the material again. In the next set of parameters, you'll be able to set your feed rates. Of course, for drills, the plunge rate will be applied as well as the spindle speed. If you route, or if you choose in end mill and choose to route to exact diameter, of course, it will also apply the standard feed rate when it's moving across the X and the Y axis. And then here, of course, you also have your spindle speed that you can set. For tapping, your machine would need the certain specifics to be able to do this. So if you want to tap threads, you'll of course need a special bit for it. And if you check this here, you'll notice that the plunge rate and the spindle speed will be matched. So if we set this to 500 RPM, it should also set this to 500. Let me just see. I'll have to look into this. All right, so as you can see, these are now matched. I cannot change this because the spindle speed is set to 500. For the thread pitch, you'll need to set up the distance between each thread on your tool. And then, of course, here you have the possibility to change the units to add this one. And basically, your machine should be able to rotate the spindle at very low speeds. And then once it's gone down to the depth that you require, it should also be able to reverse out in the same way. So it will have to rotate backwards while lifting up the tool. Otherwise, it will destroy the threads, of course. And yeah, basically, these are all the parameters that you can choose while drilling and all of the strategies as well. If you have any questions at all, please feel free to ask them. And of course, your questions don't have to necessarily relate to drilling. All right, glad you enjoyed it. You're welcome. I hope everything was clear. If you have any questions, let me know. You can always, of course, reach us at our support email, which you can find through the contact form on our website. All right. So unless anyone has any questions, I think we can conclude today's webinar. If you think of anything else, please feel free to contact us. All right, then there's nothing left for me than to wish you a very nice rest of your day. Thank you.